Good afternoon, everybody. Welcome to another episode of Shop Talk. This is mid-May, and for some, it's air conditioning system. Like where I'm at, it's air conditioning system all year long. For others, we're still kind of waiting for the weather to get a little warmer. But regardless of where you are in the country, there's going to be some new things that you're going to be facing when AC season does happen. Now, my daddy always told me that if you wanted to get the facts straight, you go to the experts. And when it comes to AC and cooling, one of the experts that I always go to is a gentleman by the name of Steve Schaeber. He is the manager of service training for the Mobile Air Conditioning Society worldwide. Steve, welcome to Shop Talk.
Thanks, Pete. Glad to be here.
Yeah, I appreciate you being able to come on today. Let's just kind of start off in general. We've been talking about 1234 YF for a long time now. I think everybody who may be watching this may be kind of familiar with how we got where we are now, but I still think there's some misinformation going on. So let's tackle the one. As a recap, we know that it all started because of what happened over in Europe, and they insisted on getting rid of 134A. Now we see a lot of 1234 YF cars here in states, but they're not doing it because 134A has been banned in the United States, are they?
Well, not really. I mean, there's kind of a couple reasons why we're doing it here, which I guess it does have its roots back in the 04, 06, 2011, 2014, whatever year you want to call it, with the regulations that happened in Europe. Because the bottom line is that these guys who design and build our air conditioners, they have to build their cars and trucks for a worldwide market. And as we all know, it's a lot easier if you can keep things consistent. So if we can do YF in Europe and do YF here, it makes things easier for everybody.
Yeah, well, I mean, some of us know that, and maybe not everybody's watching it knows, but we know that there was a phase down, or there is going to be a phase down of 134A in the United States. But again, it's not a ban. Any vehicle that has that gas in it is still going to be able to be serviced with 134A. I guess what I'm trying to say is I don't want anybody confused out there. We're thinking we're looking back at the old R12 stuff again. There's not going to be any retrofits, right? We're not, in fact, we don't want to have anything to do with anything like that. We're just simply kind of, to put it another way, maybe we're just kind of graduating to the next best type of refrigerant to use in the automobile.
Right. Yeah, and some of that does have to do with some regulations here in the U.S. too. So EPA did pass a regulation probably about 4 years ago, which at the time it said that by 2021 we weren't going to be allowed to use HFC-based refrigerants, which basically is R134A, not allowed to use them in mobile systems anymore, beginning with the 2021 model year. Now, that doesn't mean that we're going to stop, like you said, we're not going to stop using 134A, just that the car manufacturers aren't going to use it when they build new systems. But if you've been following the news, a lot of that's been challenged in court. So right now, I would definitely say it's up in the air as far as that hard date of 2021. But again, that's kind of another, that would be sort of step two as far as why we're switching over to YF. The third reason, probably the biggest reason why so many manufacturers are switching in the US is because EPA gives these guys CAFE credits for using environmentally friendly refrigerants.
Right.
So if you really look at what the driving force is in the US, it's those CAFE credits.
Yeah, I know. So go ahead.
Yeah, well, I mean, you take companies like Chrysler, for example, or FCA. They build a lot of these high horsepower, off the lot. They're race cars aren't exactly the best gas mileage,
right?
So they can help offset that a little bit by using these AC credits for doing automatic recirc, for using electronically controlled compressors, and for using refrigerants like YF.
Now that's really kind of an interesting point because, like you said, that's really been the driving force, and in my mind, that almost makes the 2021 deadline for 134 kind of a secondary point. Maybe it's because the manufacturers are taking the advantage of those credits, which kind of technically makes the refrigerant circuit part of the emission system, doesn't it?
Yeah, and that's part of the reason why it's part of the reason why we're not allowed to do retrofits and why we're not allowed to switch refrigerants over like we used to do 25 years ago. Because EPA offers these CAFE credits to the OEs, they consider that if we're letting you put YF in and we're giving you an emissions credit for that, then technically that refrigerant, being lower global warming potential and better for the environment, is actually helping with the vehicle's emissions over its entire lifespan.
Right.
So if in the shop side, if we were to take that YF refrigerant where the OE got credits, emissions credits, if we take that out and put in a 134A, which is higher global warming, doesn't get the credits, they consider that to be emissions tampering, which I guess, for guys like me in Pennsylvania, be the same thing as if I just took the catalytic converter off my car and car wouldn't pass emissions.
Right. Yeah. So, and I'm just going to say, I mean, that comes with some hefty fines, if you do something like that.
Yeah, and I think right now they raised the fine back in beginning of 2018. So now the fine is like $44,500. That's basically the fine that EPA.
Yeah.
So if they catch you doing two things, you'll get two fines, 44,000 each. 10 things, 10 fines, 44. That's kind of how they do things. So.
Well, I guess too. I mean, just for those who might even have that inkling in the back of their mind, of saving their customers money or thinking about, because Lord knows I can go onto eBay and buy the adapters I need to put one into the other without too much of a problem, But the other part of that comes is that while the gases are similar, they're not identical. So the system is designed to work best with the gas it was designed for, right? So.
Yeah, and again, going back to the OE guys that design these systems, I mean, they spend countless hours in wind tunnels and doing road testing at their testing sites and on regular roads. Seeing how these things perform. What do we have to do to tweak the system? Yeah. And we've talked a little bit about the one major component that sort of has changed over for the new YF is this inline heat exchanger. Which basically helps to transfer more of the heat from the refrigerant while it's circulating around in the system to make YF work better. But what a lot of guys don't think about with the system is the expansion valve itself. And, they're actually calibrated to a specific superheat for the evaporator. So if you look at the superheat for 134A, and I'm just pulling some rough numbers out here, you may have 6 or 7 degrees of superheat for that refrigerant, for that size evaporator. But, for YF, it may be completely different. And I'm not throwing out hard numbers here again, because it all depends on the size of the system, but you may be at 9 or 10 degrees. And if you're using the wrong refrigerant in the wrong system, then the expansion valve doesn't work right. And you may send the wrong, you may send too much liquid back to the compressor. So, we know what that does.
So. Yeah. And that's kind of like, I mean, we think we learned our lessons in the R12 days, right? I mean, back in those days, we could switch over and put 134 in the systems, certain things we were supposed to do in the process. But even with that, there are a lot of instances where you had to add an extra fan, in order to make it work and cool the cabin. So, if you're thinking about even considering that, if it's anywhere even on your horizon, just forget about it. It's not worth it. But going along with that now too are some other things that have kind of come to light. Let's hit the first one I can think of. When you're working, and those talking to the text notes, like when you're working on these 1234 YF systems, first of all, refrigerant systems in general are getting smaller. They're holding less refrigerant, and that's kind of remarkable when you think about it. I mean, they're still pulling out the same heat load out of these cabins, and they're doing it on almost nothing in terms of refrigerant capacity. So these systems have gotten highly technical, highly efficient, right? So when you're going to work on these things, because of that smaller quantity, if there's any leaks, you got to find them, and you got to fix them, because that one size leak now represents a bigger proportion of the whole when you compare them to the size of the system, right?
Right. And something else to think about too, besides the refrigerant side, is the refrigerant oil sides,
Right.
refrigerant oil side.
Yeah, absolutely.
So, the like you said, the charge levels are going down. So, in one of my clinics this past spring, I had a slide I used that compared, and you can do this yourself. Just go out and look at the charge label under the hood of a 2000 F-150 and compare it to a 2017. And you'll see that the systems are using about 30% less refrigerant to cool roughly the same size cabin, but they're using about 70% less oil
Wow.
than the systems were 20 years ago.
Wow.
And again, this goes back to the EPA with those EPA CAFE credits. A lot of your new compressors, beginning back about 2016 or so, they're starting to use what's called an oil separator. So it's basically a little device that they put into the discharge port of the compressor. And as the refrigerant is leaving, basically as the compressor is blowing the refrigerant out, in some of the designs, the refrigerant gets a sling to it as it's leaving because of the shape of this device. And it literally slings the oil out of solution so the oil can dribble back down the sides of the discharge chamber and go into a little reservoir inside the compressor.
Oh, okay.
So, a lot of us are used to using a lot of oil. We're used to putting in, 6-8 ounces in some cases. So, if you'd look at again, back to this 2017 F-150, it only uses 2.7 ounces of oil.
Wow.
Which is, let's take my little 20-ounce jar here. It's about that much.
Yeah, right. Yeah,
it's really small.
It's about a shot glass.
Yeah, it's not a lot.
That's not a lot. Wow. I mean, you think about it, that's really kind of a mind bender. You have to wrap your head around that one. I mean, and that kind of brings up a few questions. We are talking about locating these leaks. Of course, now 1234YF, you're talking about a much more expensive refrigerant. So, if you didn't diagnose those leaks, gentlemen and ladies, and you send that customer on down the road before the season hits, they're going to be back because they're not being cooled anymore. Again, you're looking at maybe as the identical size leak that was okay 10 years ago is going to empty the system out before the end of season, or at least make an impact on system operation nowadays because of that smaller quantity. But not only that, but that customer's not going to be real happy about paying you to fill their system up again. So when we're looking at leak repair, of course there's sniffers, but since we're on the topic of oil, I think what I want to talk about next are dyes. So Steve, what is MACS's position? What do you teach your audiences when it comes to the impact of number one, using too much dye, and number two, how well in these newer systems that are keeping most of the oil in the compressor, how well is that dye finding its way through the rest of the system?
Yeah, so dye is there's actually a lot of interesting information about dye, and we think of it as just such a very simple thing: pour in a little bit of dye, let it circulate, look around with a black light, find the leak, everything's great. But there's a couple of misconceptions about it. First of all, I guess going to how much dye. Too much dye is not good. So basically, as you add, and there's two reasons for it. Number one, when you pour dye in, the dye is actually just a small, basically a dry chemical that's mixed in with some sort of a carrier oil. Usually a PAG oil, could be POE, depending on what the system uses. I'm going
to throw that in right there, because that's a very important point that I want people to make sure they heard. First of all, that dye's got to match the system you're putting it in.
Right.
Yes. And I'm referencing any electric compressor systems that you might find yourself diagnosing. You may think you're doing the right thing, and you grab your little injector tool with dye and you throw that 1/4 ounce in there. But if that 1/4 ounce had a PAG carrier, man, you just bought the farm, right? So
yeah, because the PAG, is lower. It's more susceptible to.
Yeah. Anyway,
so you want to make sure that you use the right. Yeah, and it's important. And as far as how much dye, and you can kind of do this test on your own in your shop. We all have bottles of dye laying around. So if you take your dye and take a dye light, some kind of a black light, and shine it on your bottle of concentrated dye, so what you're going to use to pour in. But then if you took that same dye and added it in the right amount to the right amount of oil for that system and look at the difference, it's kind of like, the concentrated dye is concentrated, so you've got a lot of that dye chemical, that dry chemical mixed in with the oil is concentrated in a small amount of dye oil. Where when you put it in with your oil and refrigerant in a system, it spreads out. So this is what you have to think about. It's those tiny dry chemical particles that actually reflect. So if you have too much of it jammed into one spot and you try to reflect it with your dye light, it's not going to do as well as if it's spread out throughout a lot of oil and a lot of refrigerant.
Oh, okay.
So it's completely opposite of what you think. More dye is not better. And some guys will say, well, I'm going to add a little bit of dye because, the vehicle may be 10 or 12 years old. The dye may be starting to wear out. But in actuality, what you end up doing is you put in so much dye that it doesn't reflect as well as if you had just that tiny amount from, the original formulation that, whatever it's supposed to be, 1/8 per pound, or however they decide to formulate.
Very good point.
Yeah.
And then too, with the circulation, I mean, if you're dealing with these systems that are keeping the oil in the sump, in the compressor, that stuff's not going to circulate in an hour, right? I mean, you're going to have to allow it some time to move through the system.
Yeah, and especially with these oil separator systems that are using a lot less oil. I've been told that, if you look at, I know we all read the Federal Register and, the actual specifications EPA uses.
Right.
But they give the credit to the OE as long as the oil separator can keep out 50% of the oil out of circulation.
Okay.
But in reality, these compressors are keeping about 97 to 98% of the oil out of circulation.
Wow.
But when you talk to the dye manufacturers, they say that, I know that that's not a lot circulating around, but as long as we have 2 to 3% running around in the system, that's enough for the oil to, coat the whole inside of the condenser and the evaporator and the lines. And, it's going to carry the oil and dye, and we're going to be there when the leak happens.
Right.
So you're still going to see the dye.
It kind of goes to what you were saying. Little is better than more. Right.
Right. So and it kind of helps in a way.
Right. Yeah, you would think.
Yeah.
That kind of makes sense. The other thing, too, that I think we need to let everybody make sure they're aware of is that many of the OEMs already have dye in them from the factory.
Correct. I mean, not all, but most.
Yeah.
And when you look at the OEs that do, they put it into most of their vehicles, but not all.
Right.
So you really have to, use your best judgment as a, experienced technician. If you're working on a system that may be 6 or 7 years old, if it already has dye in it from the factory, probably not going to have to add a lot of dye to that system because it already has the original dye.
Yeah.
They do say that dye will start to lose its effectiveness over time. But again, with our experience, you get your light, you look and see, well, if it's reflecting and I'm seeing maybe a little bit of dye on the service port and I see that it's glowing, then, the dye that's in the system is going to be glowing the same amount.
Right. And it's kind of neat because the neat thing, fellas and ladies who are watching, the neat thing about the MACS conference, it's also one of the times of the year where the SAE Interior Climate Control Committee meets. And I know they have their own, meeting during the MACS conference. And I know we met some of those at the February conference, and this subject came up. And I put a little bug in the ear of, I can't remember the gentleman's name. Of course, Peter Cole, that we both know is there as well. For you who don't know, check out our April webinar. He was a co-host there, and he's also the chairman, current chairman of the service committee, service tool committee. Is that right? Subcommittee of the Interior Climate Control Committee.
Yep. Service subcommittee. Yep.
And we were talking about why see if they can just add a standard to the standard. Something on the underhood label that lets you know that dye was installed at the original build from the factory. Yeah. So who knows? We'll see what that happens. If you see that on the stickers, you're welcome. my idea.
Yeah, we would love to see that. I
Yeah, it
mean,
would make things easier,
especially
right?
right. I mean, me personally, I mean, coming from the field and knowing what it's like every day, I would love to see oil charge amounts. I would love to see an indication of dye on the label.
Yeah.
Um, but the 630, what I call the J639 label, that SAE standard J639 goes way back to before even the 1950s.
Wow.
And that's what we call our umbrella.
Yeah.
It's our overarching uh, safety standard.
Hmm.
Um, there's a lot of people that have input over that. It's basically the entire Interior Climate Control Committee, and making everybody agree on it's a little bit,
I'm sure.
you
I'm
got
sure.
hundreds of people, it's difficult. So,
Yeah, I'm sure.
yeah.
And I guess one more thing I want to get into before we let you go, because we're talking on the focus really on 1234 today, the machines. One of the things I heard at the conference were reports of some firms, companies out there offering R134 cabinets as 1234 YF equipment. All they did was change the ends on the hoses and then claiming them as retrofit equipment. I think we should address that because there's some very good reasons, gentlemen, if you're looking and you haven't made that investment yet, um, why not to buy that equipment. You need to get one that's certified to the 1234 standard. So, Steve, if you could give us some highlights of why the two cabinets are different, what those differences are.
Yeah, so we have two standards in SAE that have, again, these are years working on these standards. And basically, the standard is for not only the performance of the recovery machine itself. So when we wrote the standard for the YF machines, we wanted the machines to, perform the same way that our 134As did. We want that plus or minus 1 ounce of accuracy for recovery and recharge. We want that 95% recovery amount within 30 minutes. But with the YF, we had to take into consideration the flammability of the material. So the two main things about the standard are anti-arcing switches and solenoid valves, because we don't want to create anything that may be a spark in the machine itself, and also purging the cabinet. So a lot of these machines, they have big plastic cabinets that encase all the inner workings.
Mm-hmm.
So if you think about it, if one of the internal lines or maybe the tank or one of the valves has a leak, and overnight, say that YF is slowly coming out and filling up that cabinet, you could imagine what problems you may have the next morning if technician rolls the cart over to a vehicle, turns it on, and if the cart didn't do something to help mitigate that. So basically what happens, one of the things in the standard is that as soon as the machine is turned on, the first thing it does is it goes through an air change to purge all the air out of the inside of the cabinet to get rid of anything just in case something had vented. So that being said, we write these standards. The machine manufacturers that make these machines, they follow the standards. They actually help us write them. But you always have these unscrupulous guys out there, and everyone's trying to make a buck. But you got some guys out there that are taking some older equipment, maybe that wasn't working so well with 134A or whatever, and they decide, well, I'm going to convert this over and let it work with 1234 YF. And then going a step further, some of these guys are trying to sell them. So the ones that we've seen so far, the machines are obviously just swapped over with a couple of fittings to make everything connect. But the bottom line is these guys aren't, buying and reading the SAE standards that we wrote and putting into place the safety parameters that we did when we wrote the standards.
Yeah.
So that's our big concern with guys buying these buying these out, say some online website.
Yeah. And there's a few other benefits to those machines as well. First is requirement to perform a refrigerant identification before you can recover what's in the car. I mean, nowadays you really don't know what's inside that system, especially with all the do-it-yourself products that are out there in the market and the thousands of YouTube experts. You can always go and search Dr. Google and get your answers there online, right? So it's to protect yourself and your equipment. That's a good feature. Of course, at the magazine and at MACS, That's just a best practice to do that on any vehicle that you're servicing. Is to check the, the identifications first. One other note too, I want to make sure everybody who's listening understands that yes, Steve explained all these safety features that are included in the 1234 YF cabinet. It is classified as mildly flammable, but to make something clear, everything under the hood of the car is flammable, pretty much, right? I mean, to some extent. So we don't want you, I'm not trying to paint a picture that, oh my God, you're dealing with propane, in this machine. That's not the case, nowhere near that. But so these cabinets are over-engineered on the side of safety, right? Because we all know that if you give a human being something to mess with, sooner or later they're going to have a boo-boo and have a problem. So we want to make sure that they're over-engineered for that. Same with the system on the vehicle. For example, the evaporator core on these vehicles that use 1234 YF is certified for that refrigerant. It's different. That's why you cannot send it out for repair. You can't replace it with one that is not certified. And again, it's there. It's an over-engineered safety factor since the evaporator is inside the cabin of the vehicle. Steve, one last thing. Everybody who's watching, not this past, but the year before in January when the EPA said you had to have your little 609 card if you wanted to buy refrigerant. I know you guys got really busy.
Yeah, it was an interesting year. Yeah, there was a lot of guys, not only, young new technicians starting out that came to MACS to get their 609 cards, but a lot of us guys, that have been working for 20, 25 years, that we needed our MACS cards back in the 90s to buy refrigerant when, they put a lot of the stores put the purchase restriction in place on R12. We lost those cards. We never really had to have them for 134A until about a year and a half ago. So we got a lot of requests from guys that misplaced their cards or ones that got, soiled in some way and wanted a new copy. So that was a lot of our time also.
Yeah, but I'm sure there's still a few of you watching who don't have that certification in your pocket. Go to the MACS website. That's macsw.org, right?
Yep.
Yeah, that's the MACS website. You can get information about the 609 program there. And I'm going to tell you this. I mean, I know there was also some talk at the conference about recertification, much like we do with our ASE certifications. Of course, if you have your 609, it has nothing to do with how well you can troubleshoot or repair the system. It's primarily the safe handling of refrigerants. However, there's been a lot of changes made. So there are some best practice information in there. 1234 is covered. I think, if I'm not mistaken, R744 is also kind of mentioned, though we're really not looking at seeing that anytime soon. So if you haven't redone your certification, I know you don't have to, but I'm going to encourage you, for the small amount of costs, take the exam, take the test again. Go through that material again. You'll find it to be a very good refresher. And I stress, as I'm sure Steve would, these systems today are so much more efficient. They're so, like Steve pointed out, the refrigerant quantities down 30% on average. Oil quantities down, what did you say, 70% on average?
Yeah, in some systems, yeah.
Yeah, in some systems. So, it's just like all the other systems that you hear us talking about on the vehicle today. You're literally driving a hot rod in every way, shape, and form, and you can't. They don't allow you the same margin of error as they did way back in the old days. You've got to do it right. That's all there is to it, and that's one of the reasons that we like to bring you Shop Talk and bring you experts like Steve. Steve, thanks so much for taking the time to hang out with me today.
Yeah, you got it, Pete. Anytime. Thank you.